Yeah, my name is Tom Schamberger. I'm a cloud data engineer working for MSG. And I want to show you something about our work regarding real-time analytics and especially how to implement real-time analytics in AWS. I think a very relevant topics. Yeah, let's begin. So, who's MSG? So, hopefully you have heard us. If not, MSG is the fifth largest IT consultancy in Germany. We have 10,000 employees, are based in East Mining, Munich. We are mainly in the DACH region, but we operate in 32 countries. We were founded in 1980, and we are best known for our work in insurance and in banking. But we are also operating in consumer products, food, healthcare, in the public sector, telecommunications, travel and logistics, and so on. We are a strong group of many companies. We have a lot of also a lot of startups, interesting products. And yeah, we showcase some of them at our stand, on the AWS stand. So just come to our stand, and we can show you all about our products. So what do we do? So we basically do a lot of software as a service, infrastructure as a service, and a lot of other offers. We do cloud consulting, cloud software development. We do integrations and migrations, so bringing applications into the cloud, cloud operations, also cloud DevOps and so on, and combining services, so security and so on, using new requirements to integrate it into solutions, into cloud architecture and so on. So this is basically the whole portfolio, what the whole MSG group does. But our division, we specialize in cloud data platforms. So what's a cloud data platform? What we do is we help businesses to become data-centric, to use data for their decisions. So basically you can use a lot of different things for decisions. You can use your experience, you can use gut feelings and so on. But the best way to take decisions in a company is based on data, based on insights. And this is the reason why we do reporting in companies. So what we do is we take data from whole over the company, from marketing, from production, and so on, and shift it into the cloud. And there we can do a lot of analytics, and we can have insights, and so on. And we can feed those insights again into different use cases, and to make better decisions, and to become data-centric. And we help our clients to really go through that journey. So we base everything on a cloud infrastructure we built. We ingest data from SAP, from Salesforce, from databases, and so on. And we use different tools to bring the data into the cloud. We then use different tools, from Snowflake to Databricks, Spark, and so on, Flink, to process this data. And then we build applications on it. We build reporting use cases on it. We build AI use cases on it, and so on. And we can automate this with CI/CD. We have data governance, so we implement data governance so that the data quality so we monitor the data quality, data catalogs, and so on. And so usually this is done in a batch mode. So data is ingested in big batches, for example, every month, every week, every day. And this is partly historic because in the past, every reports we had quarterly. We didn't have all the data at every time. And this is the reason why a lot of systems are built that we have quarterly reports or maybe monthly reports and so on. But the other reason is that because we have so huge amounts of data sometimes, we in the past just weren't able to process everything in real time. But now with the new capabilities of the cloud and with new services and so on, and also with the help of our partners such as AWS, we have the opportunity to process the data in real time and generate data in real time. But what are the challenges with the batch processing? What's the problem? So basically, we can't implement every use case. Some use cases require that I have the data in real time. So for example, I have sensors in a manufacturing plant and I monitor the temperature. And at some point I see the temperature goes up. If I have the data in real time, I can send some engineer and see call him for maintenance, or even I can just restart the machine completely automatically. So because I see there must be some problem because the temperature is much higher than I expected. But for that I need the data in real time. If I know one day later, or maybe also just 1 hour later, that I had this problem with the temperature, maybe my machine is already broken. So for many use cases, I need the data in real time. The other important point is delayed insights. We want to react quickly to insights. We want to be the first movers. If we see an advantage, companies want to take this opportunity as quickly as we can. If our competitors, or if the competitors of our clients, if they move quicker than we do, they will get the market share, they will get the clients. For example, if I know that a customer still has some, that a customer, for example, in retail, he has still something in the shopping cart, and he just went away again, and did some other stuff, and I say, he has still some products in the shopping cart. I can send him an email and remind him, hey, you still have something in your shopping cart. Maybe you want to buy this. And but I can only do those use cases if I have data in real time, and I can only build on those use cases if I have the data quickly. Also, a big problem of batch workloads is the dependency on fixed schedules. So if I know that I get only the data on Mondays, I build everything around that. Everything runs then maybe on Tuesdays, because I know, okay, on Tuesday I will have all the data on Mondays. And all my whole system is built that way that everything is on a fixed schedule. And it's very, very complicated to get out of this schedule, because everything is timed in that way historically that I get data in certain situations, and at some point I might want to implement some use case, but I say, no, I can't implement this. I get this data only on Tuesday, and I say, yes, then change the schedule, but I can't. I depend on data which I get on Monday, and this is the whole problem behind that, yeah. And data streaming can overcome those challenges. We can have more use cases, enable more use cases, not only for reporting. So the results, the artifact of my whole data platform is not to have some report with some graphs and the management says, okay, we need to invest more in that, or there's a problem. But I can automate automate this process and directly act when I see some problems, some challenges, some insights. I can directly act on the challenges, and this enables me to have that systems that systems are completely automated, and I don't need a decider in between. I can get rid of the human, and I can leverage the whole power of my analytical processing, the whole compute power of the cloud to generate insights and directly use them in my day-to-day work. Also, I stay agile. I don't have this fixed schedules and so on. I can just use data because I have it all the time. I always have the latest data. I can always use it. And this is a big opportunity to implement data streaming use cases. And we do this successfully for many customers and more. This is just a small selection we were allowed to mention in that context. But how does it work? How do our streaming use cases, how can you implement a streaming use case? So basically it looks very similar to a batch use case. You have a data stream ingestion, but the ingestion is very different. You need some CDC ingest, some direct events or API pools for that. So you have some specialized ingestion which takes directly the data from the database, from the change feed, for example, directly from the events, directly from the operating systems and so on, and you push them into some data stream storage. This is, for example, Kafka. If you are a technician, you know that. You have some streaming database, and there you feed it, and there you need to store all this data. You can keep it. You can keep it for longer time. You can keep it only for a few minutes in that data stream, but you need to have some queuing system. And from that, you can plug in some data stream processing, so you process some stream and you stream it back to the data stream storage, and you take it again and you stream it again back, and you can do a lot of different things with it. And in the end, you have some services which subscribe to this data stream storage. So some real-time monitoring, some other real-time application, some ML inference. Yeah, you can build machine learning models into that platform. And how does it look like? So it can look so data streaming platforms can have many different shapes. And we can use many different technologies for that. But AWS especially has a lot of good tools to implement it. I mean, it's not for every use case, and this is why we, as a consultancy, we try also to look at the use cases, start with the use cases, and then build up a concept which is best for our customers, for our use cases. But we see that AWS has a lot of good services, and this is a good services building upon open source software we can leverage to implement those use cases. So I have also a demo of all those tools later at the stand. So it's more of a technical demo just to show you how you can implement this, maybe also for technical people, but also I can show you just also on a more high level how that works. So everyone who is interested in that are later invited to our stand, and we can talk about it. But basically, what services can we use? So AWS has a managed Kafka. Managed Kafka is really that data stream storage, this central storage unit for data streams, which can yield data in very low latency, which can serve data across different processing systems and so on, and which is really central to this system. And the nice thing about why this Kafka service in AWS is very nice is because you don't need to handle with a lot of passwords and so on, because it integrates with the authentication service of AWS, IAM, and so identity and access management, and which allows that we don't need any passwords and so on, but real role-based authentication. It makes it everything secure, and you don't have the risk that some password is leaked or something like that. Another nice thing is that that there's a good integration with other tools. For example, with Apache Flink, we can leverage Apache Kafka streams to run on Kubernetes to integrate streaming workloads in applications on EKS, so the Kubernetes solution of AWS, and we can. And this is also a very nice thing. We can use Lambda functions to process. So in Lambda functions, a service in AWS which uses serverless computing. I don't pay for the whole workload. I only pay if I use it. And this is a very nice concept, and it's very lightweight. And for some use cases, not all, Lambdas can be a very lightweight way to process individual data points in real time. And I can integrate a SageMaker for machine learning workloads into those streaming applications, and also time stream database with Influx. They launched it this year, the Influx support and Grafana, just to have like real-time dashboards and alerting, and other services can over an API and so on also connect to this DataStream platform. So AWS offers a very nice way and uses a lot of good services based on open source software, which are very good integrated, so that we can build streaming pipelines which can process data with very high throughput and very low latency. And this is really what's that about. So, as I said, you can learn more at the stand, and we have also 3 other nice products. We have Metaverse. This is basically IoT, so this is also a data streaming use case. So we work together with for a few hotels and so on, and they have sensors in their rooms to measure the actual temperature. And this helps with the sustainability and also for cost reduction, because we can really measure what's really the temperature. And for rooms which are used, we can really make sure that the heating is off. And this is I think, a really nice use case. Another thing we do is Rantor. So this this measures the signal strength of 5G networks and sends this to the cloud and analyzes it there, so that you can make sure that your 5G networks and so on are stable and have the throughput you want. And yes, and we also talk about cloud data streaming and some other use cases in that regard. The last point I want to do is, now, yeah, we agree. Data streaming is a very nice technology. How do we start? So how we do projects is we go to our clients, and we first evaluate the tech stack, evaluate the concepts, and so on, and then we create an architecture concept, and we create diagrams and so on, and really try to focus on the use case. We are very technology agnostic there, so we have many different solutions for many different customers, and yeah, we really try to adapt to our solution to the use cases of the customer. Then we really also implement the whole cloud infrastructure, the whole data platform, and so on, with infrastructure as code, and build the pipelines and so on. But we also offer evaluation. So we look at infrastructure, we look at costs of this infrastructure, and we evaluate where can we optimize, where can we reduce costs, and so on. So this is also something we do. For example, also we do well-architectured reviews for some customers. This is something we do in aspect to AWS. So these are our contacts. So me and my boss, and of course we are a lot of other peoples. So we people at our stand and in MSG. I hope you got some insights into our work regarding real-time analytics. So thank you very much. And yeah, I'm happy to welcome you at our stand, right in the corner of the AWS stand. Yeah. So thank you.